So, because this is an honors class, we're combining lesson 23 and lesson 24. We'll come back tomorrow and catch lesson 22 on a chapel day. Lesson 22 is one of those lessons that I, don't consider to be all that important. It's one that we can not practice much or at all on this. But today's lesson is extremely important. Solving two-step equations and equations involving decimals. Now, we're building our equation skills. Maybe something that we're going to do today is a little new to you, but probably everything that we're going to do today you've seen before. So we can combine these, and we will have homework from lesson 23 and lesson 24 mixture. A little bit more homework than usual, but nothing too difficult. All right, so let's dig in. To solve two-step equations or multi-step equations, we're going to use the inverse operations, and we're going to work backwards. Right? So if an equation, for example, has addition and multiplication in it, we're going to first undo the addition or subtraction, and then we will undo the multiplication and division. That's just the way it works, right? Because we have to get the x term by itself, and then we can isolate the x term by multiplication or division. Okay? All right, so you do when you undo something, right? We're solving something. It's like we're unwrapping a present. We're going to do things in the reverse order that we would have put them together. So you're going to do the addition, subtraction, and then multiplication and division. So solve this equation, showing all the work. The process is important. What would the first step be? Why do we want to add 2 first?
Cancel it out
because we want to get the x term isolated, right? So I need to get this other term by itself. Y'all understand what I'm talking about here? There's 1, 2, 3 terms in this mathematical expression. So the first thing we will do is add 2 to both sides. I want you to show it. Plus 2, plus 2. That will give us 3x equals 10 plus 2, which is 12. Then we will divide both sides by 3, and we will get x equals 4. Now, is this an equation that you could solve mentally? Yes. Absolutely. I don't doubt that. I don't doubt that you could solve this mentally. I'm actually, it's a good thing that you can, but I want to see the process. And when I talk about the equal signs being lined up and nice and vertical, your equations, I want them to look like that. So that top to bottom, we have our equal signs lined up. Okay? All right, next example. Now, by observation, what's the answer to this equation? X equals 3. Right? You guys can solve this. What's the process involved? We will subtract 5 from both sides, right? What does that give us? 4x equals 12. And then we will divide both sides by 4. And that gives us x equals 3. Nice, top down, equal signs lined up. The process is more important than what, Jay? The answer. The process is more important than the answer. I want you to have the correct process in your problems. Okay? Now, to check it, how would we do that? Plug this 3 in to the original equation. 4 times 3 plus 5, is that equal to 17? It absolutely is. It works. Now, it's so quick and easy to check, particularly these simple equations. If you're going to solve an equation mentally, at least take the time to plug your answer in and make sure it works. Okay, just give yourself at least that much checking. All right, what's different about this? Hey, Karis. What's your question?
So if we have like an easy one, then if we can do it in our head and then like plug it in the answer.
Yeah, I'd be okay with that. But process right now, I want to see process because we're working towards some pretty difficult equations even in this unit. And having your equal signs lined up and your processes nice and clean is going to be very important. So practicing them on the easy problems just makes it sharper when it comes time to do when it's difficult. All right? What's different about this problem? Yeah, the variable's on the right instead of the left. If you don't want to work with that way, you could do what? Yeah, we have a negative coefficient. All right? If we didn't want to work it that way, what would we do? You could swap sides. Yeah, we're allowed to swap sides of an equal sign, so you could write this as negative 5n plus 6 equals 8. You just have to make sure that things stay the way they are. All right, but let's just work with it the way it is. We can do that. How would we get the x by itself here? Excuse me, the variable by itself. Sean?
You subtract 6 from both sides.
Subtract 6 from both sides.
And you get 2 equals negative 5m. Then you divide negative 5 from each side. And you get m equals negative 2 or 5.
M equals negative 2/5, which we can write either way. You could write it as m equals negative 2/5, or you could write negative 2/5 equals m.
Or could you do like negative 0.4?
No, I don't want decimals. I want you to dance with who brung you.
What? Okay, I got you.
Yeah.
I see you.
It's okay.
If it uses
Yeah,
fractions,
if we have decimals in the problem, I'm just a fraction guy. Use fractions. I would not. Who asked that question? Was that to you, Abby? Or, I wouldn't count it wrong if you put negative 0.4. But why do that extra step
make up the answer.
and mess it up? Maybe you wouldn't have to. Now watch what happens if you substitute this in fraction form. You get 5 times negative 5 times negative 2/5. Look what happens to the fractions. Right, the 5's cancel. You got positive 2. So the fraction kind of ends up working really nicely even when you check it. And that's one reason why you should never, ever, 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 ever do your answer as a mixed number. Because if you're going to plug it in with a mixed number, put a pencil in your hand and write, and then you won't be doing that. Okay? If you're going to use a mixed number and you're going to check it, then you have to change it back to a what? A fraction to multiply. Now, what is obviously different about this equation? Write this down. We have fractions, right? Jay, what are we always going to do with a problem that has fractions in it? Are you not writing this down?
Sir?
You're
Yes.
not writing. You haven't written it down yet. Have you written it down, Nick?
No, I haven't written down this question.
Okay. We have 1/2 n minus 1/3 equals 3/4. This may be new for you. How have you guys been taught to work this problem?
The same way.
The same way. Add 1/3 to both sides and then divide both sides by 1/2. That's not the way we're going to do them. Okay? What we are going to do always, y'all listening to me? How often?
Always.
Always. Unless we have a proportion that we can cross multiply, if you are given equations with fractions in them, we are going to get rid of the fraction. All right. Now, because an equation is balanced, as long as we do the same thing to every term, we can do pretty much whatever we want to do to an equation. So, what would the common denominator be for all three of these denominators? 12. So we're going to multiply this entire equation by 12. Trust me. Trust in me. Just in me. All right. What's 12 times 1/2?
6. Where did you get 12?
Common denominator.
What's 12 times negative 1/3?
4.
Negative 4.
Negative 4. 12 times 3/4? 9. Now we have an equation that we can solve by observation, right? 13 over 6 is going to be the solution. Now, is that easier or what?
It is amazing.
It's extremely easy. Now, the reason that we're allowed to do this, y'all listen, the reason that we're allowed to do this is because it's an equation. If we had two terms that were fractions, we'd be forced to get common denominators. We'd be forced to do that to combine the terms. But because we have an equation here, two sides, it's equal, it's in balance like a balance scale. As long as I do one thing to everything, I'm okay. The equation stays in balance. We are always going to eliminate fractions because it's easier and because rational equations and some of the equations that you'll be solving in Algebra 2, you don't have a choice. The only way to solve them is to get rid of fractions. So this skill is not only handy and helpful for this, but it's also extremely helpful, or it's necessary for other things. Okay? What, Karis? What? Never mind. So then we'll have 6n equals 13. You can ask me later.
I'm astonished.
Then we would divide both sides by 6 and get
13 over 6.
13 over 6, which I want you to leave as
13 over 6.
13 over 6.
Not 2 over.
Okay? Now, if you chose to do this the other way, we would add 1/3 to both sides, right?
12.
Common denominator over here is 12, so this would be 9 over 12 plus 4 over 12. You get 1/2 n equals 13 over 12. Then you either have to divide both sides by 1/2 or you have to multiply both sides by 2 over 1. And, it's just a lot messier process.
I like it, it's a lot easier.
What is? Yes, a lot of equations have to be done my way. And one reason I'm saying, again, y'all listen to me carefully. I'm not saying that you have to solve equations that way, but what I am saying is the skill that I'm teaching you here is absolutely necessary to solve some other types of equations. So practicing this skill is extremely important. Once we do it more and more, you're gonna like it. Because these are simple equations. What if we had 6 fractions in this equation? That's a lot of common denominators. That's a lot of stuff that you have to do that we're just going to get rid of immediately. Yes?
6, you would still have to find the common denominator for all 6.
Yes. To multiply. I'm not talking about the difficulty of finding the common denominator. You guys have that skill. I'm talking about all the arithmetic operations that are there. All right, so we're going to multiply by what here? 12. And we're going to get 4m. 12 times 3 halves. 2 goes into 12. 6 times 3 is 18. And that's 7. Fractions are gone. And once the fractions are eliminated, again, this becomes an equation that you could solve by observation if you needed to, if you were in a hurry. You subtract 18 from both sides. That gives us 4m equals negative 11. Divide both sides by 4, we get m equals negative 11 over 4. Okay? Now, something that is similar to this, and maybe I think probably some of you have done this before. How have you solved decimal equations in the past? Have you done anything special?
You multiply by 10.
Same way. Subtract 8 from both sides and
Well, I kind of add.
turn it into a fraction. 1/2, 10 1/2 as a fraction.
And then do
I
what you
multiply
said.
it.
Then
Do
what you
do.
said,
So here's what we're going to do. Josh, what are you saying?
I multiply everything to get all the numbers.
Yeah, you just want to get rid of decimals. We're allowed to multiply this entire equation by 10 and move all the decimals, right? And when we do that, we get 80 plus 5x equals 105.
They So if it was like 0.05, would you want to multiply times 100?
Yes.
This new.
Yes. 80 plus 5x. Now what do we do here? Hey, Karis, what's up?
You're killing Abby.
I know. So we're going to subtract 80 from both sides. And we get 5x equals 25 and x equals 5.
Yay. Oh, that's
Okay? Now, x equals 5 is the solution. Now that's easier than the other ways of doing this. It's easier than doing decimal operations. It's easier than, you know.
You multiply by 1,000.
If we multiply through by 1,000, all of our decimal places will move 3 places, right? So that will give us 6a plus 20 equals 200. And now I bet you can see the answer, can't you? A is 30. Now, could you see the answer the other way? No, you can't. But as soon as you use this tool, one of the things that we're allowed to do to equations is multiply the entire equation by whatever we want to multiply by. And we will use that skill to eliminate fractions and to eliminate decimals. Always. Subtract 20 from both sides, we get 6a equals 180. Divide by 6, we get a equals 30. Now, if you want to skip those steps, actually showing those things and just writing these like this, I'm okay with that for now too. All right? What's up, Peyton?
I'm leaving for golf. Is there going to be like a video to watch on YouTube?
Yes. I'm actually filming it in your class too, so you'll miss what they miss. All right. See ya. All right. 2 more examples. Yes.
Nothing.
The death stare.
I stopped myself. I did not stare.
I mean, she raised your hand when you call on her. She acts like it's your fault.
Nothing.
What's wrong with you, Mr. Hinton?
That's why I
Quit
didn't
talking to
realize.
me.
Like, what? And I was like, nothing.
You did raise your hand. You went,
But I
all right, what do we need to do here? Karis, what do we need to do here?
You need to multiply.
Ah, right. But let's write an equation first.
But that takes so much.
It really doesn't.
Your new way is not helping you with this one.
It really doesn't. This one, it doesn't help much. We need to 0.48 times 86 equals x. Right? The word of tells us to multiply. Right? Now, this becomes a tedious little decimal multiplication problem. We're not going to spend the time to do that. You know, if you multiplied both sides by 100, you still have to multiply 48 times 86 equals 100x. It doesn't really help us a bunch, right? This is just one operation. We're not going to be able to undo that one operation. Right? We just have to multiply that out. What do you get when you multiply 0.48 times 86? Yes? 41 point. Is that exact? 41.28 sounds better to me.
Yeah, that's right. Sure.
Last problem. Last problem. The average height of a mandrill, that's a large species of baboon, I'm sorry, is, y'all listen, it is 2.54 centimeters more than 12 times the length of its tail. Now, here we go. I have no idea if it's true. I have no idea what a mandrill is. All right. Okay. Are y'all ready? All right. I need the equation from the sentence. What do you think, Elizabeth? Can you give me an equation here?
plus 2.54.
Okay. All right. So y'all watch. Here's the equation statement. The height of the mandrel is. Give me that. H equals 2.54 more than 12 times the length of its tail. 12 times T plus 2.54.
It's 78.74.
Okay. Now, then it says, if the height is 78.74, that's giving us a value that we can plug in for H right here. What is the length of its tail? We can plug it in for H and solve for T. And this, Elizabeth, this may be something similar to what you told me a second ago.
Yeah.
2.54. All right, y'all want to get rid of these decimals? Leave the decimals?
Get rid of
Get rid of
them.
It's a lot.
If we get rid of them, we have 1,200. Let's keep them this time. Subtract 2.54. Subtract 2.54. And that gives us 76.2 equals 12t. Divide both sides by 12. What's 76.2 divided by 12? Let me punch that in.
It's 6.5. No, see, that's 6.5.
76.2, it is 6.5.
No, it's lower than that. Just the 2.
Divided by 12. 6.35. The tail is equal to 6.35 centimeters.
I did.
Okay, so baby tail.
Do you want us to do the
It's a very
decimals
silly
always?
tail.
Because I just did it.
No, you don't.
Well, I mean, it's only 78 centimeters.
Now, there may be some times, guys, this particular problem, you look ahead, I just don't see where it's going to save us a whole lot of time to do the multiplying everything by 100.
It's already taken.
You got to divide by 1,200 at the end. Now, here's what kind of I don't like about this problem. You guys asked a large species of baboon.
And it's this tall.
Yeah,
Population.
78.74 centimeters.
That's like
a
2 feet.
meter.
Very
That's
tall.
that's like just a little over 3/4 of a meter, right? 75
That's
centimeters.
pretty big for a baboon, though.
No, not really.
Is it?
No.
Big as Luke.
That's not what I'm thinking. When I think of baboons, I'm thinking
An
big.
orangutan.
So big.
All right, y'all listen up. Shh. There we go. Out of control. Just that quick. Nick starts singing. I'm ignoring you. All right. Here's our 2 homework pages for tonight. It's probably 5 more problems than we would normally have, but you can handle it.